Hi, my name's Roy and welcome to another M3d video tutorial. In this tutorial we're going to construct a small gear. Hopefully this is going to give you some insight into the drawing tools, some of the basic morphology, and give you a few tips and tricks too. So the gear we're going to construct is a 12-tooth 1.5 module gear. The first thing we're going to need to do is construct the pitch circle of the gear. So if we go here to the circle center radius tool, click that. It's now asking for a circle center. I'm going to type in 0 space 0. It's going to give me a circle centered on the work plane. Now it's asking for the radius. This is a tip in M3d. You can actually type in very basic numeric expressions on the command line and they get evaluated. So for this circle, the radius is going to be 12 teeth times modulo of 1.5 divided by 2. Okay, so that gives us our pitch circle for the gear. I'm just going to increase the size of the work plane to encompass more of the drawing area. So I go to Tools, Work Plane Size, and type in 50. And that just makes my work plane a bit bigger. We now need to construct the base circle for the gear, from which the involute is unwrapped, which gives the tooth profile. So I'm going to create a horizontal line from the center of this circle out horizontally here. So if I go over here and turn on ortho snap, the line will snap to the horizontal position. Okay. If I escape out of that command, as it's recursive, I now need a line which extends at the tooth pressure angle direction. So I can go to line, point and angle here. Now it's asking for a point to start the line. And if I go, another important key concept are the points acquisitions tools in M3d. So I want a point which is actually the intersection of two curves. So I can select intersection under the right mouse button menu. And now if I pick those two curves, hopefully the intersection will be returned into the command here. That's asking for an angle. The angle is 20 plus 90, so that's the pressure angle, plus 90 degrees. And then we have a line in that direction. Okay. So I now need a line which extends from the center of the circle normal to this line here. Another single line command. So pick that. Now if I pick on the point on the circle, hopefully it will return the center point. Or as you can see, ortho is still turned on. I'm just going to turn that off. Now I need to use the points acquisition tool again, which is project. So I right mouse button and select project. Now if I pick the curve I want to project a point to, which is that one, and then I pick the point. There we go. It's generated a line normal to the pressure line. We can now create the base circle. So I want the circle center and point command here. Now if I pick the center and I want the point there, which is the intersection of these two lines, so again right click and select intersection between that line and that line, cancel. We now have the base circle for the gear. We now need to construct the involute profile for the gear. So for this we need the base circle radius. So if I click on the circle, right click and do information, it'll write out some information about the circle, one of which is the radius, which is here, so we need that. If I double click on that, it will highlight it, and right click and copy it, copies it to the clipboard. Now copy and paste does not work with Control C and Control V, you have to right click on the window. Okay, now I have this spreadsheet which is packaged with M3d, which generates involute points. All I need to do is paste that radius into this cell, and it should generate all the points which define the involute. Now if I highlight these points here, do Control C, copy them from Excel, and now go back to M3d. Okay. So if we go to the points create tool here, okay, this is recursive. I can paste in those values, and as you can see, it's generated all the points along the involute. Can now fit a spline to those generated points. If we go here to the spline fit tool and just pick points along the profile. Don't have to pick all of the points unless depends on how accurate you want to be. So that's the point selected, and if I press the middle mouse button, it's equivalent to a enter command, and it's now asking for the order. We'll just accept order 2 for the curve, and there we have it. We have a spline fitted to those points, which defines our gear profile. We can now get rid of the points that we generated. They were just for construction. So if I go to the filter tool, right click the mouse button and go to filter and pick points only, pick only. I can drag a box out which selects all the points and then press the delete key. Okay, so we now have our first part of the profile for the gear tooth. Okay, I'm just going to change the colour of our pitch circle to distinguish it. Pick that, and we go down here, we have the palette tool. I'm just going to change it to red and OK. Right, we now need to create the dedendum and addendum circles. So I can use the offset command here. So if I select the offset command and type in the offset distance, which is going to be for the dedendum 1.5 times 1.25, and then if I select the pitch circle and then click to the side I want to offset it, that's giving us the dedendum circle. Right click and cancel out of that command. I now need the addendum. So let's go to offset again, and this is just the module, which is 1.5. Click that and offset it in that direction. Now using the trim command we can trim these lines back to the addendum and dedendum circles. As you can see, if I pick the line I want to trim and then the curve I want to trim to, it will trim it back. So there we have the first part of the profile of our tooth. We now need to reflect that part of the profile to give us the other half of the gear. So I need to construct a line from the center here to the intersection of the profile with the pitch circle. So right click and intersection, pick that and pick that. Okay. We need to now rotate that line in increments of 7.5 degrees, which will describe out the position of all the parts of the gear profile. So if I select that line and go to the copy rotate 2D tool here, so I click that, it says pick objects to rotate, so I've picked the line. If I middle click the mouse button, that's done. Pick point in the XY plane to rotate about, and it's just 0. Enter the angle, which is 7.5 degrees, and the number of copies is 4. We can now reflect this side of the profile to complete the gear tooth about this line. So we can use the 2D reflect tool here, and we select the curve. So if I go filter and curve, pick only, just to make sure we just pick the curves. I pick that one and and press enter. And now we need to pick the line to reflect about. If I right click and filter, pick point only. So we want to reflect about this line, and there we have it. We can now clean this up, and we've got our first tooth which can be copy rotated. So I'm going to select those curves and delete them. Filter, curve, pick only. We can get rid of all of this now. Press delete, cancel. Okay, we can now trim the addendum curve back to give us the tooth tip. So let's trim. Now I can trim that to there and that to there. Okay, let's delete that as well. And we don't need that. Okay, so we have our gear tooth. Now we can copy rotate that and hopefully we'll have a gear profile. So we can go to the copy rotate tool here, pick the curves to rotate, so filter curve, pick only, pick that, that, and middle mouse button is the done. Point to rotate about, type in 0, 0, an angle of 30 degrees and 11 copies. And there we have a full gear profile. Okay, I have forgotten to add the root fillet radius to the gear before we copied it, so I'm not going to go back, but I'll just show you how to add the fillet. So if we go to the fillet tool here and type in the radius, which is I think 0.3 times 1.5, and then it's asking me to pick two curves. So if I pick that curve and that curve and that curve and that curve, it'll add in a tangent circle. We can now trim those circles back to give us the fillet. So if we go to the trim command, I want to trim from there back to there, trim from there to there, from there to there. It gives us that fillet. And on this side, I want to trim from where to where. I want to trim from there to there, to there. Okay, so that's put the fillet radius in on our gear tooth. If I'd have done that from the beginning, it would have copied around, but that's given us our profile. And that concludes this tutorial. Thanks for listening.